I'm John Herford from ProClass, the General Manager there. I'm going to talk to you a little bit about how we arrive at your grades, how cotton's actually classed and tested today. I won't bang on about ProClass too much, but just a bit of an idea of who we are, and if you've grown cotton before, there's a good chance we've classed your cotton. If you're growing cotton for the first time this year, I think there's probably a good chance that we'll class that. So we're a joint venture between growers, merchants and classes. You can see the split there of 40-40-20, growers, merchants and classes. And we're the only classing entity with this unique ownership structure operating in Australia currently. So the classing process starts basically at the gin, where they take a sample from each side of the bale, put a ticket in the sample there with a barcode and a unique number, which obviously matches an identical ticket back on the bale at the gin. Dispatched to the classing room every day. We'll get a sample from every bale. At ProClass, we take these samples and manually place them into these cardboard trays in lots of 30. And there's 9 trays to a rack with all the appropriate labelling on the front, so we know what's in each tray. The first part, after that's done, the next part of the process is to condition samples because we're looking to increase the moisture content of the sample. The reason for this is that moisture levels will affect the length and strength result, so we're looking for a range of 6.75 to 8.25%. Generally, gin samples will come to us about 5.5 or 6. The reason why it's important is because if it is drier than that, the fibre will be weak and measure shorter and brittle, or if it's higher than that, it will measure too long and strong. So we're looking for a moisture content pretty much in the middle of that range if we can, even though that whole range is acceptable. The idea being if we tested at 7.5% here, that bale, that sample goes somewhere else in Australia or somewhere else in the world, they do the right thing, tested at that level, the result should be the same. It's a worldwide standard. So 24 hours in these conditions, 21 degrees plus or minus 1 degree, and 65% plus or minus 2% should achieve that sample moisture level for us. So the idea being samples received today, we class tomorrow. It doesn't always work like that. We've got backlogs and things to work out, but generally we try to aim for 4 to 5 days after ginning in the middle of the season is our turnaround time. After the 24 hours in the conditioning lab, samples are tested on HVI for 5 core parameters, length, strength, micronair, colour and leaf. The machines also test for an array of other measurements as well, including short fibre index, uniformity, elongation, moisture. But those 5 there, as I'm sure has been mentioned this morning, are the key parameters for your final price, premiums, discounts and things like that. At the moment, final colour and leaf grade are determined by manual classing, so the machine is measuring colour and leaf, but at this stage classes are still overriding that with a manual colour and leaf grade, which is determined by comparing to a physical standard that we purchase from the USDA every year. I've actually got a few of them here with me today if I want to look at them afterwards. So that's a HVI 1000 machine manufactured by a company called Uster in Knoxville. Currently these machines cost around about $500,000 each. We've got 6 of those here in Gundy. We've got another classing facility out in Griffith. We've got another 4 of those currently. Obviously it's a significant investment, but that's the gear you've got to have. So the process for length is we measure 2 samples, approximately 700 fibres each, taken from 1 sample. Samples are brushed out, measured with infrared. Average length is then the final result. Results are measured in inches and grouped in staple lengths. So that's a picture of the length strength module of the machine at the start of the process. There's 2 samples in there. It'll take 2 combs, brush it out there with that brusher. There's the second sample waiting to be brushed. And there's the sample waiting to go into the what we call the tower. There's an infrared light in there that'll measure the length of each fibre and give us an average. And you can see the beard's gone into the tower, and this is the final result and how they're grouped. So the result comes out in inches. So we're looking at 1.11 inches to 1.13 is 36 staple. So that's 1 inch and 1/8. 36 staple is base, so anything short on that is going to attract a discount of some degree. Obviously, the lower the staple, the higher the discount. 37 staple seems to be the desirable range at the moment. There's no premiums for any longer that I know of. I'll stand corrected if that's the case, but obviously the longer the better, and the more longer cotton we produce, the better our reputation is, I guess. This is the stuff I just went through. Base staple is 36, 37 plus desirable. Current varieties produce good lengths in both irrigated and dryland cotton. Any variety will produce shorter fibre under severe heat or water stress, and that obviously means dryland cotton is more susceptible to staple discounts than dryland. This is very uncommon, but if you've got cotton that's of a borderline length and they're genet a little bit vigorously, you may lose a little bit there, but that doesn't happen a lot these days. Strength is measured during the same process, so those pictures I showed earlier, the strength's happening at the same time. The length is measured first, the sample is then broken, with the amount of force required to break the fibres converted into grams per tex. 28 GPT is the base strength, but 30 plus is where we want to be. Micronair is an indication of the thickness of the fibre wall, measured on a HVI using airflow versus constant mass of fibres. So we get 9.5 to 10.5 grams of fibre, compress it into a fixed volume chamber. As you can see there, little scales. There's the chamber, move it into. Known air force push through that. Resistance is measured. There's an algorithm that converts that into a Micronair result. This is how we group Micronair, G0 to G7, G5 as being the base grade. Discounts for low mic and high mic. So there is a point where Micronair can get too high, and that's when we get up to this G6 is 5.0 to 5.2. That can be a concern in both irrigated and dryland cotton in Australia, depending on sort of the conditions at finishing time. Hot and dry conditions can push Micronair up higher than where we want it to be in both irrigated and dryland. Low Micronair is generally linked to immature fibre, can be attributed to an earlier than ideal defoliation, cooler weather conditions, higher than ideal top bowl proportion, bottom bowl. These are vague ideas that, or sort of knowledge that I've gathered over a while. I'm sure there's other guys here that have spoken about this or can speak to you with more certainty about this, but these are generally the things that can cause fibre parameter issues. High Micronair, as I said before, generally associated with hot, dry conditions and can also at times be attributed to a lack of top crop. So if you've got no bolls in the top, cotton matures from the bottom up, so Micronair is pretty well linked to maturity. High Micronair bolls on the bottom, low Micronair on the top. If you've got none at the top, average is going to suggest that you're going to end up with a higher than ideal Micronair result. Same with low, but the opposite. No bolls on the bottom, bolls on the top, your average is going to suggest on the lower end. Process for colour is done both visually by a trained classer and on HVI, as I touched on earlier. Currently, visual grade is final, and what you're paid on as a grower. 5 major classes being white, light spot, spot, tinged and yellow stain. Each of these major classes demonstrate an increasing degree of yellowness. So your cotton will start out white, that's what you want it to be. As you increase the yellowness, which means it's probably been affected by moisture or something like that, it'll start to look browny, orangey, yellow, and that's not what we want. So we want it to be white. And within each major class, the brightness of each is assessed across another 8 levels. So you can have a nice, bright, white, highly reflective piece of cotton, which is of a higher grade, and it can get down into what you would even call grey, depending on the conditions it's been picked under generally. 25 physical grades for colour and 5 below grades. So here's a chart demonstrating the colour grades. So mainly we are operating with these 4 here. In any given year, this is the top 4 grades. 95% of Australian cotton will fall into those categories. Obviously, the lower the number, the better. So you've got 11s, 21s and 31s. 31 being base grade is what you want. 41s being the first level of discount. And I think Pete talked a little bit about what sort of discounts you can expect from colour earlier. So they're your white grades. These are the light spot, spotted, tinged and yellow stain ones. Things are starting to get pretty nasty in this area here from a discount point of view. We really want to stay away from that if we can. And any given year, even last year, 90 to 95% will fall into this category. It's just the proportion of where in the category that sort of affects everything mostly. So the process of actually determining the grade for a trained classer is compared to a standard box, which I've got some to look at later if you'd like to. Purchased from the USDA every year. Each box demonstrates the appropriate colour for its designated grade. That's what they look like in the shelf. Cotton colour is influenced almost exclusively by prevailing weather conditions from the time a boll opens to harvest. So a cotton boll will open on a plant, and that's the best it's ever going to be from a colour point of view. It can only stay the same or get worse, depending on the amount of colour, that's the amount of weather, rain that it's had on it. So the worst thing that can possibly happen is you have cotton opens, gets rain, and rains for several days and have overcast conditions for a week. It just gets worse and worse. Allowing cotton to dry if conditions allow after a rain event before harvesting can somewhat mitigate colour deterioration. So some people will say that colour can be bleached, it can get bad, and then from a weather event, and then you leave it for weeks afterwards in nice sunny weather, and that will bleach it back to a base grade. I don't necessarily believe in that. I think the faster it dries, the less damage is done in the first place. So I don't see there's any science linked to that theory at all, but I certainly don't believe it. Cotton harvest wet or exposed to wet conditions for a long period of time is at risk of increasing yellowness. So that's picking cotton wet, basically, and shoving it into a module, wrapping it up, locking that moisture in over sitting in a gin yard for a period of time is going to increase the yellowness. So we're going to start to get into those nasty grades I spoke about earlier, the 22s, the 32s, 33s, 34s, etc. In a really extreme circumstances, modules can get wet in a field, in a flood situation, and that'll cause the same thing as well. Like I said before, base grade is 31. 11s and 21s can occasionally achieve a little premium, but not a lot. All other grades attract a discount at varying levels. Visual leaf is determined at the same time as colour, so within those same boxes, for a box that's got 31 base grade colour, it'll also show us the amount of leaf for a 3 leaf, which is the base leaf grade. So the leaf grades range from 1 through 7, with 3 being base. The lower the number, the less leaf there is. Obviously the better. Some of the causes of high leaf grades or discount leaf grades, poor defoliation and or picking practices. Leaf can be removed from the lint at the gin to a certain extent, but there will be a point at some point where it's uneconomical for both the gin, for their input costs, and the grower with your loss of lint to remove leaf from the lint. That's just a judgment you're going to have to make at the time, I guess, with what's happening. The more modern way to class cotton, even though we're overriding that, is through HVI. So all our machines are capable of HVI testing for colour and leaf. There's a camera on the machine there that is taking a picture. With the Xenon flash, it's not that different to what's on your phone. It's calculating the brightness or the reflectance of the sample and the degree of yellowness in the sample as well. Both those results are plotted on a chart. This is called the Hunter-Nickerson chart for cotton colour. Basically, you've got RD, so that's your reflectance down this side, how bright it is on this axis, and this is your degree of yellowness on this axis. What we're looking for, those 4 grades I showed you before, is basically here. This is the top, I guess, 15% of this chart is where our cotton falls, year in, year out. Most of this is never used, only on the very poorest stuff. So yeah, you've got two measured qualities plotted on a chart to arrive at your grade. HVI leaf is measured at the same time. It's a similar process. It's taking different measurements, the number of particles in a sample and the aggregate percent area that those particles cover on a sample. Both measurements are used in an algorithm rather than a chart. I don't know what the algorithm is or how they come up with it, but both measurements are used to determine the leaf grade in HVI measurement. So that's the things that are measured and how we do it. It's obviously important to make sure that those results are right as we're doing it. So we have a calibration process, obviously, to ensure the machines are working correctly, measuring correctly. The way we do that, we buy known value material from the USDA. So we buy cotton that's a known length, a known long length and strong, a known short weak cotton with a known value. Same with microneedle, high and low. And we use those cottons to calibrate the machine. We tell the machine this piece of cotton is 5.5 mic, calibrate around that. We do that at the start of every shift, so twice a day in our busy period, and then at every break we check that calibration with known value cotton. We don't actually calibrate it, but we'll get some known value cotton, run it through. As long as it's measuring in tolerance to what the known values are, we keep testing. If there's a discrepancy there of any description for any parameter, we recalibrate the machine when that happens. This is an example of the cotton that we buy. As you see there, this is long strong cotton. It just tells us that the length is 1.201 and the strength is 33.0, and here's some short weak stuff, 0.961 inches and 22.6 strength. So it's extremely low and pretty high, and that's how we present it to the machine. Microneedle works the same way as I mentioned. There's the low mic and the high mic, 5.54 and 2.75. Present that to the machine, tell it what it's supposed to be measuring, and it'll calibrate itself from there. Machine calibration of colour. We have tiles rather than cotton because cotton lint the colour will deteriorate over a very short period of time. So we don't use cotton itself to calibrate the machine for colour. We use tiles with a set RD and plus B values, and we buy a new set of those every year to ensure they're correct. There's an example of the tiles, 5 tiles there with the RD and plus B values given to us by the USDA, and that's a trash tile with known area and count values there. Like I said before, calibration takes place prior to a shift and checked every 2 hours through known value cottons. Results of check are outside appropriate tolerances, the machine is recalibrated. That's pretty much all I've got. Thank you. It's not the most riveting process, I understand, and it's much more interesting if you come and have a look one day. Happy to show anyone around.